Assalamualaikum and good day. The first chapter of Engineering Mathematics 1 is complex number. In this chapter, there are four main subtopics, which are standard form, operations, the Cartesian plane, modulus, and arguments. Okay, I believe that all of you already has the idea what is complex number, right? So you have learned about complex number in your previous level, all right? So before we proceed furthermore into what is complex number, okay, let us recall a little bit what is the classification of numbers. Right, usually we know that number is real numbers. Okay, it's involved with real numbers, where real numbers are divided into two. Okay, which is the first one irrational number, and the second one is rational numbers. Right, so in rational number it can be divided into few more numbers like integers, whole numbers, and natural numbers. Right, I will help you to recall all of these numbers as well as the what is complex number, okay, in the next slide. Where in the next slide I will share with you a video of introduction of a complex number, where it will recall all the types of numbers, including the explanations about complex number. Okay, let us watch the video in the next slide. Okay, so how was it enough to recall all the skills and the knowledge of real numbers and complex number? I hope so. Okay, so what we can simplify from the video, okay, we can use this picture, okay, this figure to represent what is real numbers. Okay, so you must be wondering, why do we need to study complex number, right? Okay, the first important thing when we study complex number is because there are many applications involved with a complex number, especially in electrical engineering, quantum mechanics, and so on. So as an engineer, you'll be using complex number to solve the real problems in engineering. Alright, so apart from that, from the side of mathematics, okay, mathematical field, right, it helps us to solve any polynomial equation, okay, that has no real solution. Alright, so for example, like this quadratic equation, okay, this two quadratic equation has no real solution. Okay, so this has been explained in detail in the video, okay, in the previous video, so I don't need to explain this anymore. Okay, so you know how you now know how complex number or imaginary numbers is introduced. So by introducing the imaginary number, okay, which is I equal to the square root of -1, or we also can use I squared, that is equal to -1. Alright, and in some books, alright, reference book, instead of using I, they also use J to represent the imaginary number. So you can use both, either I or J, to represent imaginary number. Alright, By introducing this imaginary number, now the previous quadratic equation, which has no real solution, now can be solved by combining the real number and the imaginary number. Okay, so for example, like this, okay, where z is complex number, okay, to denote complex number, okay, 2 here is the real part, okay, real number, and here negative 3i is the imaginary number or the imaginary part. Okay, so complex number, which we denote as z, must consist of real part plus with the imaginary part. Okay, thus the algebraic equation that do not have the real solution, okay, such as x squared minus 9, x squared plus 9 equal to 0. Okay, this is the quadratic equation that has no solution. But by using the complex number, now we can solve this quadratic equation into this, where x is equal to plus minus of square root of negative 9. Alright, so when we introduce the imaginary number I, okay, which is equal to square root of negative 1, now this quadratic equation, okay, can be expressed, okay, has the solution where x is equal to plus minus 3i. How do we get plus minus 3i? Okay, this is the continuation of this. This is plus minus. This is equal to 9. Okay, multiply with the square root of negative 1. Okay, so plus minus square root of negative 9. We separate them into the products of square root 9, okay, multiply with the square root of negative 1. Okay, so this is equivalent to, what is the square root of 9? It is 3. So what is square root of negative 1? Square root of negative 1 is I. Alright, so I. Okay, so the quadratic equation that at first, okay, has no solution, now has the solution of x equal to plus minus 3i. Okay, so it consists only the imaginary part or imaginary number. Okay, so the real part is at 0 lah. Okay, right. You can use, okay, the complex number I equal to square root of negative 1 here, okay, or I squared equal to negative 1 here to simplify the higher order of imaginary number. Okay, for example, if you have I to the power of 3, okay, this is equivalent to the product of I squared dot I. Okay, so you must hold to the basic, okay, which is I square. Okay, I square. Hold to this basic, okay, and use this to help you simplify the a higher order of imaginary number. Okay, so I cube, okay, equal to the basic is I square. Okay, so the highest power of I that we can use to simplify is square. Okay, so I cube equal to the product of I square dot I. Okay, now we can replace I square with -1. Okay, so in here I square equal to -1. Okay, I will remain I. Okay, so you don't need to replace this I with this. Okay, you don't need to do that. Okay, because we want to simplify the imaginary number, so you can leave this higher order in imaginary number. Okay, so -1 multiplied with I equivalent to -I. Now, if I to the power of 4, okay, you can simplify this to the I squared power 2. Okay, to the power 2, where I squared inside the bracket here is equal to -1, and squared here is squared here. So -1 squared equivalent to 1. Okay, so now if your I to the power of odd number, it will give you imaginary number. Okay, but if your I to the power of even number, okay, it will give you real number. Okay, so if you don't believe me, look at I to the power of 5, where 5 is odd. Okay, and you can simplify this to I to the power of I squared, okay, to the power of 2, which give you I to the power of 4, multiply with I, that will give you I to the power of 5. And when you simplify this, okay, I to the power of 2 to the power of 2, that will give you 1. Okay, so this equal to 1. 1 multiplied with the remaining I, that will give you I. So this is imaginary number. Okay, so let us see the last example, which is I to the power of 6, which is even number, to the power of even number. You can simplify this to I squared to the power of 3. So this is equivalent to, what is I squared? I squared is -1. -1 to the power of 3 is -1. So what is this? This is real number. So what can we conclude from the simplification of higher order of imaginary number? Okay, if your imaginary number is to the power of odd number, that will give you the imaginary number, and if your imaginary number is to the power of even number, that will give you the real number. Okay, whether it is positive or negative, that is the only difference. Okay. Alright, so you can try to simplify I to the power of 7. Okay, so by looking at this, your imaginary number is to the power of odd number. So you know that it will give you the imaginary number. Okay, so it is either positive or negative. That will depend to the power of your negative one. Alright, so I leave this for you to try. Okay, so let us have a quick try to this question. Okay, you have the answer over here. You can try this later on your own. Okay, so A, it is 3i to the power of 8. So you can simplify this to 3i to the power of 2 to the power of 4. 4 times 2 will give you I to the power of 8. Okay, so this is equivalent to 3. What is I squared? I squared is -1 to the power of 4. Okay, so -1 to the power of even number, that will give you positive numbers, which is 1. So 3 times 1 is 3. Okay, so B, it is negative 2 to multiply with I to the power of 99. You can simplify that to negative 2. Okay, so go to the basic, which is I to the power of 2. And what will give us at least 99 or 98, which is 49, I think. So 49 will give you, so 49 times 2, 18, 8. Right, 98. So we have one more I, remaining I, that will give us I to the power 98 dot I power of 1. This will give us I to the power of 99. Alright? Okay, so this one, bring it to here. Okay, so you have this. Okay. Alright, so proceed. This is minus 2. What is I to the power of, this is that 49 dot I. Okay, so negative 1 to the power of odd number, that will give you negative 1. Okay, negative number times with I, that will give you minus 2 multiply with minus 1, that will give you 2I. Okay, so 2I. Right, so I leave it C for you to try. Okay, and the answer is here. You can check later. Okay, so now you know what is complex number. Okay, so complex number, the idea is to solve the polynomial equation, okay, that has no real solution. Alright, so that in our daily problem, in the real life, we are not only solving the real numbers problem, okay, we also can solve the problems that is impossible to solve before, okay, but after the introduction of imaginary number, now we can solve the problem. Okay, so complex number, where we denote it by Z. Okay, so Z is the complex number. Okay, it is the combination of, okay, so Z is combination of real number plus with imaginary number. Okay, so where real number can be all these number, okay, all these numbers, while imaginary number is the multiplication of real number with the square root of -1, where we can represent square root of -1 by using I or G. Okay. Okay, so this is the proper way of writing the complex number. Okay, where complex number is equal to E plus BI. Okay, so E is the real part or real number. Okay, and B is the imaginary part of the Z. Okay, so B here is actually the real number. Okay, multiply, since it multiply with I, so it becomes the imaginary part, while A is the real part. Alright. Right, beside writing complex number in the form of equation, okay, a plus bi, alright, complex number also can be plotted as a point, okay, on the Cartesian plane. Okay, so we can plot complex number z into x-axis and y-axis so that z can be represented in a form of point. Alright, so the rule is, okay, you plot the real part, okay, in the x-axis, okay, while the imaginary part will be your y-axis. Okay, so this is y-axis, right? Okay, so y-axis is for your imaginary part. In other words, it is for B. Okay, while the x-axis, okay, is your real part, for your real part. Okay, in other words, it is for A. Okay, while you do that, you plot for A and for B, you will get a point on a Cartesian plane where we write it as ZAB. So when you see ZAB, you know that point is complex number A for x-axis, B for y-axis, which is the imaginary part. Okay, where this is actually equivalent to A plus bi. Okay, real part of the complex number, and this is imaginary part of the complex number. Okay. Okay, let us try few examples to test the knowledge that we have learned in the previous slides. Okay, so let us look at whether we can apply or we can't apply our knowledge of complex number. Okay. Okay, here we need to express in the standard form, okay, of a complex number. So when it is mentioned standard form of complex number, okay, you must has the idea that the standard form is z equal to a plus bi. Okay, this is always be the standard form we write the complex number. Okay, so please remember this. This is the standard form of the complex number. Okay, so if you look at the first example here, okay, we have z equal to 1 minus the square root of negative 25. So we already knew that it is impossible to find the square root of negative number, right? Unless we substitute the square root of negative number by imaginary number. Okay, so what we can do to A is we can rewrite this, okay, 1 minus, okay, make a bracket, okay, so you transform square root of 25 into the multiplication of square root 25 with square root of negative 1. Okay, so the purpose we do this so that later we can substitute square root of negative 1 with imaginary number. Alright, so here we have 1 minus, what is the square root of 25? It is 5. Okay, so square root of 25 now can give us a real number, which is 5. And what we do to square root of negative 1? Just replace this by I. Okay, now we have the standard form of complex number z equal to 1 minus 5i. So this is your A, and the whole thing here is your B. Okay, so A is equal to 1 and B is equal to negative 5i. Okay, so easy peasy. Alright, so for B is z equal to 4 plus square root of negative 16. We can separate this by writing it negative 16 multiplied with negative square root of 1. Okay, so this is remain as 4. What is the square root of 16? It is 4. Okay, what is the square root of negative 1? It is I. Okay, so now we have transformed B into standard form where z is equal to 4 plus 4i. Okay, piece of cake. Now, let's say if we have two complex numbers, okay, and if we want to compare the two complex number, alright, we can say that z1 is equal to z2 whenever A is equal to C and B is equal to D. Okay, so from here, let's say your z1 is A plus BI, and you have another one complex number denoted as z2, okay, equal to C plus DI. Okay, you can claim that z1, okay, here is equal to z2 whenever you can prove that A is equal to C and B is equal to D. Alright, only then you can say that these two complex numbers are equal. Okay, if A is not equal to C or B is not equal to D, okay, that proves Z1 is not equal to Z2. Okay, so either one of these, if you fail to prove they are equal, okay, it means that the two complex number was not equal. Okay, by using that definition, okay, it can help us to identify the unknowns. Okay, so if you claim that Z1 is equal to Z2, okay, that will help you to solve A. Okay, so you can find the unknown Y and X here. Alright, so it means here from Z1 equal to Z2, so A of 1 must be equal to C of 2. Okay, and B of 1 must be equal to D of 2. Okay, so what A1 here is 2. What is C2? C2 is 4x. So we have one equation here. What is B1? B1 is negative 3, okay? It's not 3 but negative 3 because our standard form, don't forget, it is A plus BI. Okay, so whenever it is minus 3I, it means here that A is plus with negative BI. Okay, So that's why for B1 here it is negative 3. Okay, so what is negative 3 equal to? D of 2. D of 2 is 9. Oh, sorry, negative 3y. Okay, so we have second equation. Now we can solve this equation. We have x is equal to half, and we can solve for unknown y, which is minus 3. Okay, so I leave B for you to try. Okay, to test